Hello again, welcome back. This is the third part of the problem we've been working using differential equations. This time we've been asked to determine the position x as a function of time. So we'll work from this result that we had earlier, and we will express velocity as the time derivative of position dx dt. Separate the variables. And now we can take an integral of both sides. The integral of dx is x. I'm going to remove the constant here, and we have e to the t minus 1 over e to the t plus 1 dt. So this is not a standard integral. We're going to have to do a little bit of algebraic manipulation on the integrand here in order to get this into a form that we can easily integrate. So I'm going to take the approach here of rewriting the numerator as e to the plus 1 minus 2. So that's equivalent to what we had over e to the t plus 1. And now I'm going to split the fraction here into two parts so that we'll have a sum of two fractions. E to the t plus 1 over e to the t plus 1 minus 2 over e to the t plus 1. I'll just put some brackets here now. So all of this is the integrand. So this clearly equals 1. That was the point of this exercise. So I have the integral of 1 minus 2 over e to the t plus 1 dt. I can separate these into the two integrals, integral of 1 dt minus the integral of 2 over e to the t plus 1 dt. That's trivial. This one here will probably, let's see, I think that we could take the approach of a substitution method and see how we go with that. Remember, if it doesn't work the first time, we can always come back and try again. Integral of 1 times dt is t. Now, for this one, I will replace e to the t plus 1 with a new variable u. So I'm going to have to stop and think about what to do with my infinitesimal dt. I'll just go across to the side here. I will say let u equal e to the t plus 1. du dt would equal e to the t. So du over e to the t should equal dt. We can make the substitution now. dt is du over e to the t. Well, that didn't work perhaps as well as we hoped. We were hoping that we'd get something that would cancel. But we're not done yet. We can keep trying here a little bit. So we have 2 over u. Now, the du is fine. That's necessary. It's this e to the t that is a little bit of a nuisance. If we look back from where we were here, we could express e to the t as u subtract 1. So this is really 1 over u subtract 1 instead of 1 over e to the t. This now looks like we could solve this with partial fractions. So I might distribute the number 30. So 30 multiplied by t minus, now if I bring this constant 2 to the front and then multiply the 30, I'll have 60 by the integral of 1 over u times u minus 1 du. And that's the integral that I'm going to solve with partial fractions. So I'll just make a note that I can come back to this point a little bit later on. And what I want to do is write an equivalent sum instead of 1 over u times u minus 1, I want some constant over u plus some different constant over u minus 1. Now if I cross multiply here, I would have a times u minus 1 plus b times u over the common denominator of u outside u minus 1. By looking at the numerators on the extreme left and extreme right, we can conclude therefore that 1 must equal a times u minus 1 plus b times u. And we solve here for a and b. Remember, u is a variable. U was the variable involved in our integrand here. So we can let u take any convenient value we like. And the convenient value that I'm thinking at the moment, let's try when we let u equals 0. If u equals 0, the left-hand side is still 1. This will be negative 1 times a. 1 would equal negative a. And 0 times b is, of course, nothing. So I can quickly conclude then that a must equal negative 1. Now, the other convenient value for u would be positive 1. Let u equal positive 1. So I'll have my expression 1 equals, this time this term will disappear, and I'll just have 1 times b. So b equals positive 1, a equals negative 1. That's what I'll use substituted here as a substitute for this integrand. So I will go back, continuing my work from this point here from equation 1. And this expression started, this was x all the way down the page. This was x equaled 30 multiplied by t minus 60 by the integral. Now here's where I will use this form. So a was negative 1, I have negative 1 over u, plus b was positive 1 over u minus 1, and all of that integral was with respect to the variable u. Now these are straightforward integrals to perform, so I think we'll be good to go. 30t minus, now the integral of 1 over u would be ln u. There would be a negative 60 multiplied by this, negative 1. So in effect there would be positive 60 times ln of u for this multiplied by the integral of our first term. In the next one we will have negative 60 times 1, that's negative 60, multiplied by ln of u minus 1. And remember, we should divide through by the derivative of this expression. Derivative of this is positive 1. It won't change anything. We've performed our integration, and this is the place where we will add our constant of integration at the bottom. Now I'll need to just go over the page to continue this. At this point, we will evaluate our constant of integration. I note from the original conditions given in the question that they said initially the object was at the origin, x0 was 0. This means that we can say that at the point where t equals 0, the position x equals 0. I'll substitute these now. So we have 0 equals 30 t is 0 plus 60 times the ln of u. Now, u, remember, from back here, u was e to the t plus 1. So, e to the power of 0 for time plus 1. Now we have minus 60 times the ln of, remember u was e to the t, so e to the 0 plus 1. This term also has minus 1. And finally we have plus c. This will simplify pretty well. 30 times nothing is nothing. E to the power of 0 is 1. This is ln of 2. I have 60 times the ln of 2 from the second term. 60 times the ln of 2. What do we have here? Well, I have e to the power of 0 is 1. 1 plus 1 is 2. 2 minus 1 is 1. ln of 1 is nothing. So really, this is negative 60 times nothing. That term disappears, and I'm left with plus c. c, therefore, would be negative 60 ln 2. I can substitute that back into the expression that we had just at the bottom of the previous page. So our expression for x becomes 30 times t plus 60 times the ln. Now instead of u, I'll put e to the t plus 1, which was our original definition for u, minus 60 by the ln of, and just here, remember u was e to the t plus 1, so minus 1 would just be e to the t. c is minus 60 by the ln of 2. So we can simplify this a bit. Straight away I notice here that I have ln of e to the t. So ln and exponent are the inverse function. This is really just t. I have negative 60 times t. So I might write that term next, negative 60 times t. I still have here plus 60 ln of e to the t plus 1 minus 60 times ln of 2. 30t minus 60, that's negative 30t, plus, I'll factor the 60 from these two terms, and I have ln of e to the t plus 1 minus ln of 2. Negative 30t plus 60. Now when we subtract these, I can write that as a single logarithm, ln of e to the t plus 1, all divided by 2. And that, I think, is about as easy simplified as we can get. And this is my final expression for position as a function of time in this question.